So I am going to attempt to explain the relationship between volume and temperature with Charles' law. So Charles' law dictates that as long as the pressure remains constant, so that means that the matter has to be able to be within an expandable container, so that the force of the particles within the container can make the walls of their container expand and equalize the pressure. And the real life example I would use for this would be what happens to a helium balloon that you leave in your car overnight and the temperature drops. So you'd be taking a helium balloon from a tank where it would be under pressure and be very cold, but then it would expand at room temperature, let's say 70-degree room temperature. Stay that way, and then you quickly take the balloon out to your car, and your car is at 70 degrees, and you drive around, the balloons are happy and bouncing around in your back seat at 70 degrees in your car, and then you park your car and turn off the engine and turn off the heater. And in that cold temperature, as the temperature drops, say this would be about 75 degrees Fahrenheit or 23 degrees Celsius or 300 degrees Kelvin, it would drop down. Let's say it's really cold. Let's say it just drops and drops and drops. Oh, let's see here. I want the pressure to maintain. Let's see. Maybe it won't let me do it here because the container right now is too small. Make my container bigger so you guys can see it. And we're using small particles right now because we're talking helium, and the pressure would probably be lower than this in real life, but for our experiment's sake, I just want you to see how much slower that the particles move as they get colder. And they get colder and colder and colder, and see that container shifts or the balloon shrinks. And as the balloon shrinks, because the particles inside of it aren't taking up as much space, it's not unable to displace as much air and be lighter than air. That's the way helium balloons work. The helium plus the weight of the balloon is still lighter than the amount of air it displaces. And that's why it floats. But in order to displace that air, the balloon has to be inflated with happy, bouncy helium particles. And these helium particles bounce around a lot less at freezing and below freezing temperatures than they do at like the 80-degree temperatures. So I hope that helps you understand how Charles' law works. Charles' law, the pressure is kept constant and the volume has to be able to expand. I think the balloon can expand with the temperature. And that is why balloons shrink when the temperature decreases, because those particles are no longer bouncing around as much as they were before. It's not just because, sometimes it's because the particles escape, but in general, often when, especially with like the Mylar balloons and stuff like that, what we're seeing is them cool down, and those particles don't bounce around as much, inflating the container and displacing as much air. All right, thank you. Let's see if I can stop share and stop the video. Stop recording.